Greetings and welcome. In this session, we will discuss about the construction and working principle of Orificemeter. In the last video session, we have discussed about the first application of Bernoullisequation, that is a venture meter, about its construction and working principle. In this video session, we are going to see about the second application, that is Orificemeter of the Bernoullisequation, about its construction and working principle. Likewise, venturemeter, orificemeter is also used to measure the discharge of a fluid passing through the pipeline in industrial applications. So here, we see the pipeline passing through this pipeline. There is a fluid, and here is a fitment of orifice plate. Now, working principle of orifice meter is also same as of venture meter. That is what? By reducing the cross-sectional area of a flow passage, a pressure difference is created, which makes possible to measure the discharge, that is theoretical discharge. Here we see orifice meter construction diagram. This is a pipe section through which fluid is passing from left to right. This is an upstream part, flow in. This is a downstream part, flow out. So through this pipe section, in this pipe section, here is this plate, flat circular plate is inserted. Now as far as dimension is concerned, here pipe diameter is taken here as a D1. Orifice diameter is taken as a D1. Here third diameter, that is what? Diameter of vena contracta. Vena contracta is a least diameter of a fluid passage which occurs after the orifice plate. When the fluid is passing through this pipe, it comes across the hole, and here that is getting converged. So here we find the diameter reduced. So the least diameter where is taking place, that location is called as vena contracta. So similarly, for the pipe diameter D1, area will be A1. For the orifice circular hole diameter DO, area will be AO. For vena contracta diameter D2, area is A2. Inside this pipe, fluid is passing its specific gravity we take as a SL. Now, because of this change in a dimension, here pressure difference is created. This pressure difference is measured by using the manometer fitment. So this is a differential U-tube manometer which is fitted over this pipe section. Left side of the manometer, left limb is fitted on the inlet pipe, and right limb of this manometer is fitted at the location of vena contracta. By the pressure difference here, the level difference in the tube, in the manometer fluid is taking place. That is called as deflection of manometer fluid, which is denoted by letter Y. Inside the U-tube manometer, the fluid which is used, that is called as manometer fluid. Its specific gravity we take, or we show by notation SM, specific gravity of manometer fluid. Thickness of this plate is taken nearly equal to 0.05 times diameter of the pipe, and orifice diameter is taken half of the pipe diameter. So these are all the dimensions. Now, location of this flat circular plate is at 1.5 to 2 times of pipe diameter, and vena contracta is generally obtained at the half of pipe orifice meter diameter, half of orifice meter diameter, that is 0.5 times DO. Now, as we have seen in the diagram, construction diagram, that as like venturemeter, here we don't find the diverging cone in the orificemeter. So that is why here it has a cheaper arrangement for the discharge measurement, and installation of the orificemeter requires smaller length as compared to venturimeter. Now, orificemeter is used where the space is limited in the application for the measurement of discharge through the pipe. Now see the key parameters of the orificemeter. Here, coefficient of contraction, this is a hydraulic coefficient term. Coefficient of contraction is denoted by letter Cc, which is the ratio of area of vena contracta A2 divided by area of orifice AO. As area of vena contracta A2 is smaller than pipe area, thus value of Cc comes less than 1. This Cc parameter is used in the calculation of velocity at vena contracta, means at location 2. Velocity V2 is equal to square root of 2gh divided by square root inside the square root 1 minus ratio AO by A1 bracket square into Cc square. Further, theoretical discharge is calculated by using the formula A1 AO, means area of pipe, area of orifice multiplied by square root of 2gh divided by inside the square root of A1 square minus AO square. Then actual discharge is calculated by multiplying this theoretical discharge with CD value. CD is a coefficient of discharge of the orificemeter. It can be obtained by using the relation. So CD is equal to product of coefficient of contraction and coefficient of velocity, where coefficient of velocity is what? Ratio of actual velocity to theoretical velocity. Actual velocity is a V2. At V2, theoretical velocity is square root of 2gh. Thus, from this formula, we can arrange and we can write the formula for velocity at vena contracta, means V2 is equal to CV into square root of 2gh. CV can be calculated by using one more formula, that is ratio of these two square roots. 1 minus ratio of area square divided by, at the denominator here, 1 minus ratio of area square and Cc square. So these are the key parameters of the orificemeter. Now here we have seen that in the construction diagram, as like venturimeter, here is a no diverging cone of longer length. So that is why orifice plate is a compact in a size. So here, because of that, here when the fluid is passing through that orifice plate hole, then there, due to sudden change in an area, their loss of energy is taking place, and subsequently it leads to reduction of coefficient of discharge in a orificemeter. So that is the reason CD of orificemeter is smaller than that of venturimeter. So in this video session, we have discussed about the construction and working principle of orificemeter along with schematic diagram. Also, we have seen different parameters, key parameters in that: hydraulic coefficient, coefficient of contraction, coefficient of velocity. We have seen theoretical discharge formula. Then with the help of actual discharge formula, we find the discharge passing through the fluid, discharge of the fluid passing through the pipeline equipped with orificemeter. Let us meet in the next video session. Thank you.